Let's look at a few more examples of using substitution to solve a system of equations. It's always helpful to continue naming your equations, 1 and 2, just to help yourself keep them straight. What we'll do in this case is start with equation 2, and we'll substitute negative 5 halves x in everywhere we see y in equation 2. So we'll rewrite equation 2 as 5x minus 9 times, in place of y, we're going to substitute in negative 5 halves x, because we know from equation 1 that that's exactly equal to y, is equal to 55. Now we can simplify a little bit on the left-hand side here. We have 5x minus negative 9 times negative 5 will be negative 45. I'm sorry, that'll end up being positive 45 halves x is equal to 55. Adding 5 and 45 halves will give us 55 halves x, which is equal to 55. And then our last step to solve will be to multiply both sides by the reciprocal, 2 over 55. So the left-hand side will end up with x, and that will be equal to just 2, since 55 over 55 will cancel. We have the first half of our coordinate pair. Now we'll go back to either of the original two equations. Equation 1 is just the simpler equation, so I'll use that one. We'll rewrite this as y equals negative 5 halves times 2. So now 2 over 2 will cancel, and we'll be left with just y is equal to negative 5, giving us a solution of x equals 2, y equals negative 5 as our coordinate pair. In example 6, we're going to do pretty much exactly the same thing, but we're going to substitute equation 2 into equation 1, because in this case it's the second equation that's already solved for y. So it's much easier to take this expression that's already set equal to y and drop that into the first equation in this case. So this time we'll be looking at equation 1, and we'll rewrite this as 3x minus 5 times that expression we have in equation 2 times 4x minus 5 is equal to 8, which will become 3x. We'll distribute that minus 5 through, so this will be negative 5 times 4 will give us minus 20x plus 25 is equal to 8. We can combine the like terms. This will give us negative 17x plus 25 is equal to 8. Then we can subtract 25 from both sides to get 8 minus 25, or negative 17. And then dividing both sides by negative 17 will give us x is equal to 1. Once we have the first piece of our coordinate pair, we can go back to either of the original two equations. So this time we'll go back to equation 2 because it'll be easier to drop this in and solve from there. Equation 2 will become y equals 4 times 1 minus 5. This equation is already solved for y, so all we need to do is evaluate the right-hand side, which will be 4 minus 5, or negative 1. Giving us a solution of 1 common negative 1. In example 7, both equations are already solved for y, so it doesn't really matter which one we substitute into which equation. So in this case, we'll take equation 2 and substitute that into equation 1. So we'll rewrite equation 1 as, in place of y, we'll substitute in negative 5x plus 3 is equal to negative 3x plus 1. We can add 3x to both sides, or let's add 5x to both sides and subtract 1 from both sides to give us 2 is equal to 2x. And then dividing by 2, again, we get x is equal to 1. Then if we substitute that back into equation 2, we could have also used equation 1, but we'll use equation 2 here. We get y is equal to negative 5 times 1 plus 3, which will give us y is equal to negative 5 plus 3, or negative 2. And we end up with the coordinate pair 1, negative 2 as our solution.